Algorithms, and I'm your instructor, Nutan Dimay. So in this course, we are going to talk about the main topic is analysis and design of algorithms. You would have learned about algorithms in your data structures course. And if there is anybody in the audience who has not done the data structure course because they were away for a semester or something, maybe you can just put up your hands. So I know who has done data structures and who has not. You can think about algorithms course as a continuation of a couple of courses you did in the previous semester. The kind of thinking required in the algorithms course is similar to the discrete structures course that you did. You are required to write proofs, you are required to argue about correctness. And you can also think about it as a continuation of your discrete structure course. Of your data structure course, where you were supposed to design algorithms while keeping data structure in mind. Whereas here, the parameters that we want to optimize would typically be time complexity or some other resources that the algorithm uses. Okay, so first of all, let me just welcome you all to this yet another online semester. As you know, we have to deal with the whole semester in this online fashion. And it cannot happen unless we keep lines of communication open between us and you keep telling me how things are going for you, and I in return ask for your attention through the course. I know it is very difficult to manage online. I know it takes a lot of effort. There's no other way right now, and I hope that you will cooperate throughout the course and keep studying throughout. Okay, so let's get started with the slides. Let me ask you if you have any questions while I project my slides. The slides should be visible to you. If they are not, just leave a comment. All right. So my name is Nutan Dimay. My email address is nutan@CSE. So anytime you want to reach out to me, you could drop a mail. You could also always contact me on MS Teams. So I should be reachable definitely within 24 hours by either of these. So this course is going to get divided into a few modules, and I would like to run you through how I have planned the course. On Moodle, you would have seen that there is already an outline for the course. So I encourage you to take a look at that. So first things first, I think in every core course, you are very concerned about how the evaluations will happen. So let me get that out of the way. Course credit structure is as follows. There will be a lot of weightage for assignments and vivas. For assignments and vivas, you've been asked to create groups. So please do that exercise. It is compulsory. You have to form groups. Those who are not able to form groups of 4, you should fill up the form that has been uploaded online, and we will try to pair you off. So you will submit assignments and we will conduct vivas for groups. This will be one major component of evaluation. This will happen throughout the semester. So you are expected to basically solve the problems, understand the solutions, discuss with your group members, think about different variations if you can, etc. you should understand the problem solution extremely well. Without that, Vivas will be difficult to crack. The next component will be mid-sem. Uh, Very likely, this will be a proctored exam. How I'll do the proctoring, I will tell you over time. There will be some amount of weightage for this, around 15%. Endsem plus Viva, again there will be a Viva group wise for Endsem as well. Uh, there is there will be activities throughout the semester, peppered through the semester, which will involve your participation. In some sense, these are easy marks to score because all you have to do is voice your opinion on a poll or point out a certain thing in my slides. I will declare what counts towards class participation. A random comment on some forum will not count towards class participation. Unnecessary questions, etc., will not count towards class participation. So, class participation will be planned activities planned by us, TA team, and me, and they will be tagged as class participation or CP or something like that. And you will be asked to do them in a designated time. And once you are done with those, you will get some points for doing that. Okay. So this plus minus 5 is true for the first and the last point, even for the middle 2 points, depending on how the semester proceeds. Some of these are likely to change. They won't change very heavily unless something extremely unexpected happens. I mean, I'm just saying this because if you recall 1 year ago in this semester, things really changed drastically. And I would like to just qualify things like this, saying that, things are likely to change. These times are all fluid and there may be changes that we have to do along the way. But if the semester is proceeding as we have planned, there are no unexpected things that happen along the way, then this would be more or less the credit structure. Any questions regarding this are welcome at this point. I will pause. If you're uncomfortable unmuting yourself and asking questions, you could also leave your questions in the comments and I can address them. I'll pause for 1 whole minute, and if you don't have any questions, I'll go forward. Endsems and midsems are not group wise. What will be the frequency of assignments? Assignments will be, we are planning around 4 assignments in the whole semester. This could change, as I said. What is Viva in Endsem? So there will be a written exam followed by a Viva for the Endsem. Will there be coding assignments or theoretical? This course does not involve coding. I may mark out some problems which will be fun to code if you are interested, but there will be no credits attached to coding. Viva is individual or group wise. The Viva will be, you will be questioned in a group, but you will be asked to give an answer. A specific person will be asked to answer a specific question. So once the Viva begins, you are not allowed to discuss among yourselves. All your cameras will be on and you will directly be talking to the examiner. Will students also be doing a course project? There is no course project. Okay, fantastic. So I think current bout of questions has stopped. If you, of course, you have more questions, you can put them in the comments later and we will address them. So office hours, I'm available by appointment. So I'm not declaring a certain slot as office hour. Instead, all the students who have doubts in a particular week can write to me, and I can try to schedule a session with all of you to clear your doubts. All the TAs can also be contacted, and in fact, every will be assigned a TA. Once the groups etc. are formed, we will do that. And then TAs will also make themselves available for doubt solving. So throughout the semester, you can either contact me, but if some of you are not comfortable contacting the instructor, you could also contact the designated TA. Well, while one designated TA will be allocated to you, you can contact any TA. If you feel more comfortable with a certain TA, you can contact that TA. For doubt solving, all TAs will be accessible to you, as well as myself. So course announcements will happen both on Moodle and MS Teams. Every announcement will be repeated on both the forums. If I forget sometime, maybe the class CR can remind me that I've forgotten to announce it, but very likely I'll just announce it simultaneously on both. Moodle will send you an email instantly, and MS Teams, I will tag all of you wherever it's very important. So you should keep track of both, or rather, you can keep track of any one. Course related discussions will happen on MS Teams. So Moodle I'm not using for discussions because often students are not that happy with Moodle discussions. There are no emojis or other things. So we can just use MS Teams for queries, doubts, etc. Um, if you have not yet joined MS Teams, please do so. It is mandatory that you join MS Teams. The code is given here, the code is published on Moodle, so it is required that you join it. So that's all about credit structure. Now let me tell you the technical things that we will think about in the course. So the course, as I said, is divided into 3+1 modules. Okay, let me pause here. I think there is some question. Yeah. So do we get a set of practice problems? Is it only assignments? No. So every week you will get one tutorial sheet. The problems from there are for your practice. You are not required to submit answers for those. Assignments will be based on the concepts covered in, say, 2 tutorial sheets. So every second week or something, there will be an assignment. And that will be based on a couple of tutorial sheets that I would have published by then. Will there be any tutorial classes? So as of now, we haven't planned any tutorial classes. What happens for tutorial classes is that some students don't want it as mandatory. The doubt solving session and contacting me by email for doubt solving and TAs is a replacement for that. If a group of students feels that their TA should conduct some sort of a help session, you can bring that up with the TA and we will arrange it. From my experience in the past, I arranged these tutorial sheets, but overall in the class of around 100 students, around 20 students show up across batches, across groups, subgroups. So I have found it easier to sort of just announce a tutorial thing group by group by talking to the TA. That has worked better. So that's what we will do. Can we have model solutions uploaded for the assignments? No, we will not have any model solutions uploaded for the assignments. You will be figuring out the answers. You can share them among each other. You are allowed to upload them. We will not. Would there be recorded lectures? So there will be no recorded lectures. I'm recording my interaction right now. We will have 2 interactions per week. Attendance is not compulsory. Interactions of the videos of these lectures will be uploaded on YouTube, and we will tag it with timelines as to at what time what concept is discussed. Closer to the exam, when you want to review these videos, you could go to a specific concept within the video at that timestamp and review it. Which 2 days do we have live interactions? Live interactions will be on Monday and Tuesday. Thursday class will not happen as that time in that time slot. You are expected to spend at least 1 hour outside of these two live interactions to review the videos if you did not attend the live interactions. So, of course, if you attend the live interaction, you are required to spend at least 1 hour outside of the live sessions to review the notes, to try to solve the tutorial problems, to discuss them with your groups. If you do not attend the live interaction, you are expected to spend the time that we spend on live interactions to watch the videos at some point during the week and 1 more hour doing the other activities that I mentioned earlier. Will you be sharing the slides used in live interactions, live sessions with us? Yes, most definitely. The slides that I will be using today are already on Moodle. First tutorial sheet is also uploaded on Moodle this morning. How do we know what we solved is correct or not? You can know that by discussing with others. You can know that by talking to us. You can post your solutions and we'll correct and give you feedback as well if you want. Are we required to go through any slides before the live interaction? Yes. In all other weeks, I will upload the slides before the live interactions. Today being the very first class, I did not do it. But for example, for tomorrow's interaction, I will upload them today. For all the subsequent weeks, I will upload the lecture notes well in advance, slides well in advance. So you are encouraged to go through them. I wouldn't say required, it's not compulsory, but you can, I encourage you to go through them. If live lecture is not compulsory, then what is class participation? What class participation? Completely different set of activities that will be announced throughout the semester. Okay, keep the questions coming. Let me go over to the course outline. The course is divided into around 4 modules. I would like to call it 3+1 module. I think in the live course, I'll be definitely be able to cover 3 modules. Depending on how the progress is and how students are doing, how well they are understanding everything. If the class progress is reasonably good, I also plan to cover a 4th module. So module 1 consists of 3 algorithm paradigms. One is greedy algorithms, another is divide and conquer algorithms, and the final one is dynamic programming. These 3 programming paradigms allow you to give efficient algorithms for very different set of very large number of and very uh, varied types of problems. It's important in this module to learn where to apply greedy algorithms, where to apply divide and conquer algorithms, or where to apply dynamic programming algorithms. Often what happens is you look at a problem, and because human minds work in a certain way, we tend to apply greedy algorithms most often. But we will see that not always will greedy algorithms give the right answer. In fact, sometimes the answer provided by the greedy algorithm could be terrible. You should also know other paradigms. Specifically, dynamic programming is a wonderful paradigm where if a problem on face of it looks extremely difficult to solve, Dynamic programming allows you to solve it in an efficient way and very efficient and systematic way. It's important to internalize these three techniques as well, because they come up quite often. In fact, from an extremely practical point of view, when you graduate from IIT Bombay, if you're going into the job market, algorithms is one course which everybody will expect you to know well. So, in that sense, this is a very, very central course for computer science students, because anywhere you go, if you go into finance or something, it may be slightly different, but if you go into for any job, there is absolutely no way to sort of do well, even at the interview level for these kind of for these companies, without knowing this very basic building block. So even if you are coming into this course knowing some of these reasonably well, I still encourage you to pay very close attention to them. They are quite crucial. And in the whole course, if these three things you understand, are very confident about, I'll be quite happy. So module one is quite important, and even if you know like a subset of these, it's still important for you to understand them extremely well for different reasons going forward. Second module is for optimization problems, where you are required to find, say, the smallest, the minimum sized solution or the largest size solution, or you want to optimize a certain parameter about the input problem. The different problems we will consider here, the main paradigm will be max flow min cut. This is a very strong algorithm paradigm, and it has several applications. So max flow and min cut problems arise in several different avatars in many different problem domains, and they naturally lead to other optimization problems, and they have been solved using what is known as LP formulation and duality. So we will do these things. Of course, some of these you may not know right now. Obviously, that is okay. Uh, After having seen module 1 and module 2, where we design efficient algorithms, there is another important concept that we all need to understand. Some of you would have seen it in discrete math, that is of NP-hard problems, problems that we don't know whether have efficient solutions or not. So while module 1 and module 2 emphasize coming up with efficient algorithms, module 3 is like an acknowledgement to the fact that not everything will be solvable. We may be the smartest person on this planet, but there are still problems that may not be solvable by us. So that is like an acknowledgement of hardness that is around us. Many problems are in fact quite hard to solve. That's life basically. But we'll learn about this concept quite methodically. We will give lots of reductions. So while you may have learned what NP hardness is in your discrete math course, I doubt that you would have seen reductions between problems at a great depth. That's what will be the main focus of module 3. Of course, we can't just stop when we see the first problem. NP hardness is a bottleneck to coming up with efficient algorithms, but that does not mean that we just give up and go home. We have to come up with some solution for problems that are even NP hard, and that is module 4. Unfortunately, I don't know whether we'll have time for this, given the course content. It's quite dense. There, I know of algorithms courses that only cover module 1 for the whole course. So we'll see how the course proceeds. But ideally, I would like to tell you at least about approximation algorithms, where you say that, okay, maybe I'm not able to solve the problem exactly. But suppose you tell me, okay, you don't really need the best solution, but you can make do with a solution which is, say, factor half away from the best solution, then is that solvable in polynomial time? And such algorithms have been found for some NP-hard problems. That's what is approximation algorithms. And the second paradigm that I'm talking about in the fourth module is better than brute force algorithms. What are better than brute force algorithms? Algorithms where um, the best algorithm say runs in time 2 to the n. And now you are able to give an algorithm that is substantially better than 2 to the n. Say it's 2 to the square root n. Then that is a better than brute force algorithm. And there are a lot of such algorithms which have come into existence and are being used in some practical situations and so on. So we'll talk about those as well. So module 4 is if time permits, and module 1, 2, and 3 will certainly go in depth. So let me pause again for 1 minute and wait for your questions, if any. Okay, great. So with a show of hands, can you tell me how many of you have seen dynamic programming algorithms or anything in module 1? Just raise your hands. Keep them raised for a bit till I ask you to lower your hand. Don't lower them. Fantastic. Lots of you have seen at least something from module 1. Now, lower your hands if you've never seen dynamic programming. So, lower your hand if you've yet to see dynamic programming. So, among the raised hands, let me just check anyone. So, whoever occurs first in my list, I'm just going to ask something. So, Kaustav Sen, in what context did you see dynamic programming? Can I ask you? Or Hardik Siloia?
In data structures and algorithms, an assignment was given
I,
in
I
which you had to use dynamic programming.
okay. And you implemented it?
Uh, yeah, not like, yeah,
So the class was asked to implement or you implemented it, if I may ask?
everyone had to do it.
Everyone had to do it. Okay. Right. Okay, so now all of you can lower your hands. Another small show of hands. Can you tell me whether you've seen Maxflow min algorithms? If you have, raise your hands. Okay. Here there is the number is smaller. I suppose it must have been. So let me ask Akash Cherukuri. I'm just looking at it alphabetically and asking if you want to pass, that's fine too. So Akash, did you see it in data structures course as well?
Yes.
And was this an optional assignment or something towards the end or something like this?
Uh, like we had to use dynamic programming in some of the assignments in the data structures and like DSA labs.
Right, right. However, did you see max flow min cut as well?
Uh, Not that I know of. Maybe not by that name.
Okay,
I'm
fair
not
enough.
sure.
Yeah, that would be unlikely, I think. Yeah. Anybody else has used max flow algorithms among the raised hands? Sibashish?
Yes, ma'am. In our minor course of IE 501, it was there.
Ah, I see. I see. Which minor course was this?
Optimization, linear programming, modeling, and optimization.
Okay, fantastic. Okay, good. Okay, but I guess most of the people may not have seen max flow min cut. Many of you have seen concepts from module one. So module one is something all of us kind of completely internalize at the end of this course. Okay, so let's move forward. Um, Algorithms is an important course. I don't think I need to sell that concept to you. They are everywhere. Navigation apps on your phones are using them. Medical imaging, disease diagnosis, which is like a big thing right now, is using it. Communication apps such as Signal, Telegram, WhatsApp. You must have heard about Signal, Telegram after the recent WhatsApp controversy. Apps such as searching the internet, such as Google search, Bing, DuckDuckGo. Basically, we are just surrounded by algorithms with machine learning, etc., coming into our lives in such huge force. Literally, our life is surrounded by algorithms in some sense, and that's a good thing. In that, we are computer science students, so this is our expertise. If the world becomes more filled with algorithms, we have more stuff to do. Um, and in fact, therefore, understanding algorithms, thinking about efficiency, optimizing every time you come up with the very first algorithm, thinking about whether I can improve this sort of thinking is very important. So, while data structure course tells you the ABCs of working with algorithms, this course is going to try to force you to think about efficiency in a very active way. You cannot take it for granted. In fact, the third module will tell us that really many problems we are interested in are very hard to solve. While that, there are still a large number of problems that we are able to solve efficiently. For example, gradient descent is one such example where we are able to work efficiently, and that's why so many new algorithms in machine learning are becoming fast, useful, and so on and so forth. So, this thing of can I optimize this further? This thought process is something as a computer engineer you must internalize, and algorithms and design and analysis of algorithms is one course where you will be actively asked to think along those lines. So this is one place where you can sharpen all your weapons and get it totally into your system. So I don't think I need to tell you that algorithms is an important topic. But I would like to make one thing about studying algorithms. This is an important point. So before talking about algorithms, let me teach you how to do juggling. I don't know how many of you have tried juggling. Juggling is this sport where you have multiple objects and then you need to pass them from one hand to the other while at any given point keeping at least if there are n objects around n minus 2 in the air. So juggling is that sport. And I don't know, I will assume most of you don't know juggling. If anybody knows juggling, you can raise your hands, but I assume that in this audience, 99% people will not know juggling. So let me teach you. So there are these different types of juggling moves. They are called cascade moves. It's a type of juggling pattern where the ball passes from the left hand, goes over to the right hand, then again you have to pass it back here and so on. So you form these projectile motions and they have these equations. Okay, so once you understand these equations, which will be like basic physics course or something, you should really know juggling. So this was one slide to basically kind of teach you juggling. Do you now know juggling? So obviously not. Just by learning this theory, you are not going to know juggling. I mean, I just taught you this, but I don't know juggling either. Right? So the point is that I can give you the concepts, you can hear them, but till you do things on your own, there is absolutely no way you will be able to learn things. Okay, so in that sense, algorithms is a lot like juggling. You have to do it on your own. And here the key word is on your own. You may score well by cheating or collaborating heavily. You wouldn't have learned at the end. So you decide what you want from the course, but what I would like you to do is to actually learn on your own. Okay, so it's not embarrassing to get stuck on a problem. It's in fact natural if you are thinking about the problem for the first time. If somebody else is able to solve it faster, it helps you nothing. The amount of help you get from knowing that solution is zero. Therefore, it is very important that you do it yourself. I cannot emphasize this point more. Okay, I have spent like last 3 minutes just telling you this through this example. It is very important. Okay, so as I said, I cannot emphasize this anymore. You have to do it yourself. And to the extent you spend time on your own doing this right now, that is the less time you will spend later on getting embarrassed when you are in a job or at the actual situation where you need to think about it on your own. So here is a sort of a playground for you, a whole course, full 4 months, several weeks, which are dedicated for you to think about these things on your own. This is exactly the place where you should do it. If here you cheat or collaborate and not think about it, you are at loss. Okay? So it's important. Just like in juggling, me telling you things and you reading about them is not enough. You have to do it yourself. All right. So after that, I'm going to move on to actual concepts, etc. There are some questions here. Let me address them. Can you make students attendees? People are kicking others out of the meet for no reason. Okay, I don't know how to do that. So I just would tell you that don't kick each other out. But how do I make? Can somebody tell me how I can make people attendees? Manage permissions. Okay. Don't allow attendees to unmute. No. Let me see. Allow attendees to unmute. Who can present? Okay, maybe I should make only me. Announce when callers join or leave. I'm not able to do it right now. Maybe in the next meeting when I schedule it, I will try. Right now, I request everybody to not troll each other. Any other comments? Oh, it's done, is it? Okay, great. I changed some settings, but I guess that kind of helped. Okay, fantastic. So now let's actually get to the meat of the class today. Right. So let's start thinking about algorithms. Here is a very simple problem. You are given a number n, and you have to check whether n is prime or not. If it's prime, you output true, else you output false. Here is an algorithm that you would have maybe encoded in your whatever school or something like this when you learned programming the first time. So you set the flag to true and go from all the numbers between 1 to square root n and check whether the given number divides n or not. If it divides, make the flag false. At the end, just output the flag. So this algorithm is correct, right? This is how you would implement it. Now,
shouldn't it be 2 to root n? Because 1 will give the correct answer.
oh, 1, yeah. This should be very good. Good point. I should start from 2. Great. So now is it correct? Okay. So I assume the silence means it is correct. Can you argue its correctness? How do you show it is correct? How do you prove it? Can somebody give me a simple argument for showing that this is correct? Well, that should be easy. Yes. If a divides n, then n by a divides n. And min of a and n by a is at most square root n. That's great. That's precisely what I was going to say also. Slightly differently put, if a number is not a prime, then it has at least one factor that is at most its square root. Yeah, because if both the factors are more than its square root, then the number itself must be more than the number itself, which is a contradiction. All the factors of a number can't be more than square root of that number. Non-one factors. So that's correctness. That's easy. What is the time complexity of this? Is it polynomial? So with a show of hands, those who think this is polynomial. This is a polynomial time algorithm. Yeah, square root n is polynomial only. So all of you raise your hands if it is polynomial in n. Okay, I'm seeing like a lot of support for this. Yeah, keep going. I mean, I'll pause for half a minute. Great. So it gives me a lot of pleasure to sort of tell you that it's not polynomial because a lot of you have said it is polynomial. So why is it not polynomial? Any guesses? Linear is still, I would say, polynomial. Huh. Very good. So, couple of answers that are coming in, which are absolutely correct. Raj, Pradipta, Amit have said that in the length of the input. So this is a very important point. All of you should note this in your mind. In the length of the input, this algorithm does not run in polynomial time. Okay. What is the length the input is a number n. To write down a number n, how many bits do I require? I require log n many bits. So the length of the input, which let me call with capital N, is sort of log of n. Whereas, as some of you correctly pointed out, the runtime of this algorithm is O of square root of n. So, and square root of n is equal to what? Is what function of capital N is square root of n? So if I want f of capital N to be, say, 10 times square root n, what should f be? Where capital N is log n. Then what is f? As you said, runtime of the algorithm is indeed O of square root n, which turns out to be 2 to the order of capital N. Correct? So it is in the length of the input, the running time of this algorithm is exponential. It's not an efficient algorithm at all. It's an exponential running time algorithm. So if I ask you, can you tell me whether 3519 is a prime number or not? The number of bits you will require to write down, I'll require to write down this number is log of the number I just said. And now you will run for square root of the number many steps. That is exponential in the length of the input. And that's a lot. Right? So this naive algorithm that we have implemented using C, C++ when we first started coding, etc., is in fact not a polynomial time algorithm. It is polynomial in the parameter I used, but that parameter is not exactly the length of the input. Okay, so this is a subtle but important point, which you need to remember. Every time the analysis will happen and it will be exponential, it will be with respect to the length of the input. So correct. So last few answers are absolutely right. This is exponential in the length of the input. So note that every time any analysis that you have done for the algorithms in the past, it was done in terms of the length of the input. So if there is some manipulation of the array and there are some n numbers in the array that you need to sort, all of this will happen in the length of the array. You never had to do manipulation of a single number, and therefore this particular issue never cropped up in the algorithms you may have seen in the past. While you have implemented this specific algorithm in the past, you never thought about the time complexity that time, because maybe you did it when you were very young, first time you implemented it. So, there is some merit to revisiting some of the things we have done with the lens of this careful analysis, with this careful understanding and this new understanding of various things that we have, that we will build. Okay, so this was also to kind of tell you that the story is probably not all. One interesting thing I would like to point out here is Agrawal, Kayal and Saxena. These are three researchers. They were at IIT Kanpur in 2002. Okay. Professor Agrawal is still, Manindra Agrawal is still a faculty member at IIT Kanpur. And Neeraj Kayal and Nitin Saxena were in fact his students, BTech students that time. These three people are the ones who actually gave a polynomial time algorithm for this problem. Yeah, the problem algorithm we implement in C, C++ or we have implemented in the past is an exponential time algorithm. But in fact, this problem can be solved in polynomial time. This was a major breakthrough result that came out in 2002. And what they showed is actually this problem can be solved in polynomial time. They in fact devised an algorithm that runs in time poly in log of little n, which is polynomial in its length of input. This was a major research that was done. It is extremely celebrated result. If you just Google for Manindra Agrawal prime number, you will get it on Wikipedia. And a fantastic, very path-breaking result, in fact. Okay. So that's just an aside for you to sort of feel interested and, kind of get motivated. Right. So that's prime numbers. What I was also I'm planning to do is kind of revise this big O small o notations quickly. In the first tutorial I've uploaded, there are questions based on this. So in the last 5 minutes, let me do this. So big O notation, um, a function t of n is said to be big O of another function f of n if there is a constant c and a parameter n naught such that for all n greater than or equal to n naught, t of n is dominated by a constant factor of f of n. Okay. Quick examples. If I say t of n is n square plus 10n, then is t of n order of n square? Indeed it is. It is also order of n cube, where n cube is quite large. So obviously it is order of n cube as well. Is it order of capital N? It's not. Why not? Because no matter what constant you take, as n grows, there is no way that order n multiplied by a constant will continue to dominate a function which is growing as n square. Let t of n be 2 to the natural log of n. Is t of n in O of n? Well, indeed it is, because 2 to the natural log of n is n into some constant, and if I take another constant which is larger than this constant, then I will be able to dominate that function for all large n. Let t of n be square root n, then is it 2 to the O of log n? If you think yes, raise your hands. Yes, no? If you think yes, raise your hands. In fact, the answer is yes. T of n is square root of n. Then why is it dominated by 2 to the order log n? This is log n to the base 2. So this is because this is like some O of n. And obviously, square root n is in O of n. Because square root n is asymptotically smaller. So for example, let c be equal to 2, and for all n greater than equal to 2, you will see that square root n is smaller than 2 times n. Right? So you are able to find a constant such that for all n greater than n naught, so I'm taking n naught also equal to 2 and c also equal to 2. So for all n greater than n naught, this holds. There is a question. It is, good point. I said it is approximately, but really this is equal to n to the order 1. Yeah, because the n can be brought down and the order notation will continue to be in the exponent. So it's really this certainly dominated, this is O of n is certainly contained here. Good point. What does 2 to the O of log n mean? It means that, so what does 2 to the O of log n mean? So it is all those functions. This is not a single function. This is a class of functions such that is obtained by taking 2 to the log n and allowing any constant sitting over here. So any function that falls into a description like this is in the class 2 to the O of log n. So when I define a class, a function with order notation or omega notation, etc., around it, it means it is a function which is it is a set of functions rather than a single function. Okay, so I have overshot my time. Let's stop the video first, and I will stop the class right now. I was planning to cover a couple of more slides. You can go through them. I've uploaded, and we'll discuss them tomorrow. So how do I stop recording? Yeah.